Math 110, Test 1 review. This is covering units A through D. This review is 39 questions long. Let's get to it. Starting with solving and graphing this inequality, we're going to go ahead and first try to get all the x's on the same side. So right now we've got some x's on the left and some x's on the right, so I'm going to subtract 8x from both sides. And that gives me negative 6x. I'm also going to add 7 to both sides. And now over here I have 12. Now all I did was I added and subtracted, so that's not going to do anything to my sign. However, this next step will. I'm about to divide by a negative 6. And whenever you multiply or divide by a negative, and you're dealing with inequalities, not only does it switch the sign of the thing you're dividing by, but also it flips the inequality sign. So this ends up being x is less than negative 2. And if we were to graph that result, we just want a number line with our key point being negative 2. And then we want all the numbers less than that. So there's two ways you can write it. You can write it with an open circle in less than that, like that, because that's the direction of less than, the left. Or you can sometimes see it with a parentheses right at the negative 2. Graph the solutions to the compound inequality and write the solution in interval notation. Use brackets or parentheses where appropriate. So first we're going to graph it. Now I'm going to go ahead and graph each of these. So we have our first one. And I'm going to put a 5 there. Our second number line, I'm going to put a negative 6. Now I got to think about where negative 6 is related to 5. If 5 is there, then I might say 0 is right here. And negative 6 is over here. All right, so we've given ourselves two number lines to graph with. The first one, x is less than 5. So that has an open circle because there's no line underneath. This one says x is greater than or equal to. So since it has a line underneath, we're going to fill in that circle. Then we need to go ahead and fill one side or the other. So less than 5. What numbers are less than 5? Well, are they numbers over here, over here? Well, they're numbers to the left, like 0. And so we can have that right there. We could also have x is greater than or equal to negative 6. So greater than is going to be this side. But this says an and, okay? So an and means that we're going to compound these. We're going to put these together. And so an and means both of them to be true. So I want to look for the overlap. Where do they both happen? And it looks like if I were to just kind of put these on one number line, I would be able to get, I'm going to put it right in the same spot. We have negative 6. We have 5. We have filled in between, open circle, closed circle. Now, sometimes you see it written a little bit differently because you'll see it written closed circle with a square bracket and open circle with a parentheses, because that's the way we write it in interval notation. For example, we're going to write this as negative 6, comma, 5. We're going to use a square bracket to represent that it is closed there, and the parentheses that it is open. Absolute value equations look scarier than they are. Now, we understand already that absolute value means that what's inside is going to be positive no matter what. So really what we're saying is this isn't necessarily a 6. What's inside there could also be a negative 6. So to solve absolute value equations, what we do is we set up two equations. First one, we leave it exactly the way it is. 1/2 x minus 8 equals 6. And we go ahead and solve it, and we get plus 8 plus 8. 1/2 x equals 14. Then multiply both sides by 2, and I get x equals 28. But there's one other possibility. Since no matter what I put in there, whether it's positive or negative, it's going to end up being a positive. So I have another possibility for what 1/2 x minus 8 could equal. It might equal 6, or the other option, it could equal negative 6. Now we solve that equation in the same way. We add 8, and that gives me 2. So we have 1/2 x equals 2. Multiply both sides by 2, and I get x equals 4. Now, one mistake people do is they try to just solve it the first way and then put plus or minus, okay? But that's actually not true. Notice that this was a completely different number, and they both ended up being positive numbers. But those are our two answers. So here's an absolute value equation. But before we split it into two equations, what we're going to do is we have to get the absolute value by itself. So I'm going to start by subtracting 6. And that gives me -9 equals -3, absolute value x minus 1. Now, the absolute value is not quite by itself because we have a -3 beside it. So I'm going to divide by -3 on both sides. And when I do that, I get x minus 1 equals 3, positive 3. So x minus 1 equals positive 3. And since it's absolute value, that's going to be two equations. First, it could be x minus 1 equals 3. And then I could solve it and I get x equals 4. Or what could happen is it could be x minus 1 equals -3. And if I add 1 to both sides, I get x equals -2. So I end up with both of those as solutions. Solving and graphing this absolute value inequality. Now, the good news is the absolute value is already by itself. So what we're going to do is we're going to write it as two separate inequalities. The first one's going to be -3x plus 7 is greater than 8. Notice all I did was I erased the absolute value signs. The next thing I'm going to do is I'm going to write the same thing, -3x plus 7, except I'm going to put -8. I'm also going to flip my inequality. So because I changed the sign on the right, I'm going to flip my inequality. Now I'm going to go ahead and solve each of these. -7, -7. I'm going to do both of them at the same time to be really fancy. That gives me -3x less than -15. And this one gives me -3x is greater than 1. And so I'm going to divide both sides by -3. And again, I'm going to do both of them at the same time because that feels fancy. Notice that when I divide it by a negative, I have to flip the sign. So that's going to happen here. And I end up with those two inequalities. So in order to graph that, I'm going to graph each of them separately and then put the graphs together. So the first graph is going to be x is less than -1/3. So I'm going to go to -1/3, and it's less than that. That means I'm going to go to -1/3, but I'm going to go left back. This one says x is greater than 5, so I'm going to go to 5, and it's going to be greater than 5. Okay, so these are actually going in the opposite directions. So if I were going to graph them combined, what would I end up doing? Well, because it's an absolute value, and because I've got two of them, what this has is both of them on the same one. So I'm going to say -1/3 going this way, and 5 going this way. Now, how do we write that in interval notation? It was easy enough to write it in just inequality notation because that's what we solved it as. But in interval notation, that means we're going to write from -infinity to +infinity. Although, it doesn't go all the way from -infinity to +infinity. It goes from -infinity to -1/3. And then it pauses and it picks up over here at 5 to +infinity. And in between those, since this is an or, we're going to put a u. And that's the way we're going to write that in interval notation. Complete the ordered pairs so that each is a solution of the given linear equation. So that what that means is we're going to take the equation they give us, and we're going to plug in these x values into the equation to figure out what the y is going to be. So let's go ahead and try that. If we plug in 0 for x, we end up with y equals 0 plus 1, or y equals 1. Okay? And so if we plug in each thing for x, the next thing we plug in is that -2. And so the -2 and the -2 cancel out. So that gives me y equals to +4 plus 1, or 5. And the last one, we plug in 1 and we get a -2 plus a 1 is going to be a -1. Now what we're going to do is we're going to take these 3 ordered pairs and we're going to graph them. So the first one is 0, 1. So I'm going to go to 0, 1. The second one is -2, 5. So I'm going to go -2, 5. And the last one is 1, -1. Now, if we did this right, this should be a straight line. And it is. I think I can connect these and make a line. Now, when we're graphing these, we actually don't need all 3 points, but it's nice to look at all 3 points to make sure that they all go in a line. Graph this equation by plotting points. Now, I could make a big table, okay? I could do that. But what I want to show instead is I want to solve this for y, because I want to show you what I'm seeing. If I solve this for y, by getting the y by itself, I get 28 equals 4y. I just added 4y to both sides. Divide by 4, and I get 7 equals y. So if I were to make a table and plot a bunch of points, I don't need to plot a bunch. I only need to plot a couple. I need an x and a y. So I know my y. My y is 7. My y is 7 when I plug in what for x? Well, actually, my y is always 7. This is a constant function because the y is always 7. In fact, there's no place to plug in the x. I could plug in a 1, but there'd be no place to put it. Okay, so this is going to be that horizontal line at y equals 7. Find the slope. Now, the slope is the change of y over change of x. In other words, we're going to say delta y over delta x is our slope. And so we're just going to say, how much did the y change? From -10 to 9, it went up 19, okay? So the change was up 19. And from 2 to -3, how much did the x change? It went down 5. We're going to simplify that a little bit. I'm just going to put -19 over 5 because it doesn't simplify much. And that's my slope. Graph the following function. This function is kind of funny to look at because it's not a y equals, it's an x equals. So this is actually going to be a function where every point on that line is at x equals 6. Okay, so all of my points on my line have the same x value. This is a vertical line at x equals 6. All vertical lines are going to be x equals, and all horizontal lines are going to be y equals. Find the slope of the line if it exists. Now, does the slope of the line exist? Well, first off, how steep would you say that line is? If you tried to ski down that slope, would it be 0 as in very, very easy, or would it be a 10 as in really, really steep? Or in this case, it would be an infinity. This slope does not exist. Okay, I'm going to put D&E, stands for does not exist. The reason is because this is a vertical line. So we have x equals 5. Find the slope of the line if it exists. Okay, so imagine you're going skiing and I said, look at this hill we're going to ski down. It's very difficult. And then I'm going to say it's a 10 on 10 out of difficulty. And you'd say, no, it's not. This isn't very steep at all. The slope of this one is 0 because this is just a flat line at y equals 2. Find the slope in the y-intercept. I can do that by putting it in y equals mx plus b. So I'm going to do that by subtracting 4x from both sides. And I get y equals -4x minus b, well, minus 8. And the y-intercept tells me there's my slope. And right there is my intercept. Use the slope-intercept form to graph the equation. It's not in slope-intercept form, so the first thing I'm going to do is subtract 2x from both sides. And I get y equals -2x plus 1. My slope is -2. My y-intercept is 1. So I'm going to start by graphing my y-intercept. I'm going to go to 1. And then I'm going to move according to my slope. It says go down 2. 1, 2. And then I can't just put a point there. I need to move over. So if we don't have a denominator that tells us rise over run, we just move over 1. So I'm going to put my second point right there, and then I'm going to connect my dots. Write the equation of the line, which is a slope of 6 and passes through 4, 2. Okay, so there is an equation for this, but I have a hard time memorizing a bunch of formulas, so I'm just going to use y equals mx plus b, and I don't know b because that is not b. That's actually x and y. So what I'm going to do is I'm going to plug in the three numbers I have for three of the letters. So the y is 2, the slope is 6, and the x is 4. I don't know the b, so I'm going to leave the b as a b. So now my goal is to solve this equation to figure out what is the b. So I'm going to multiply 6 and 4, and I get 24, and I'm subtracting from both sides, and I get negative 22 equals b. Now I know b, I also know my slope, so I'm going to go ahead and rewrite it as y equals 6x minus 22. Right, the equation passes through these 2 points. It just gives me 2 points. So the first thing I'm going to do is I'm going to find my slope. My slope is my change in y over my change in x. So how much does the y increase? The y goes up 1. And how much does my x increase? It goes up 2. So I'm going to simplify that just a little bit and say my slope is 1/2. Now I know my slope and I know a couple points, but what I don't know is my y-intercept. So I'm going to use my y equals mx plus b formula, which is my slope-intercept form. Y equals mx plus b. And I'm going to plug in 3 things. I don't know the b, so I'm going to plug in b for b. But everything else, I'm going to use one of my 2 points. I could have used 3, 4, but I'm going to use 1, 3. Why not? So the y I'm going to use is the 3. The slope I have is 1/2. And the x I have is 1. Okay, now I'm just going to solve that to find b. And so if I multiply 1/2 by 1 and then I subtract from both sides, I get 2.5 equals b. Okay, now I'm going to rewrite my equation as y equals 1/2 x plus 2.5. Not 2/5. I got to watch myself here. 2.5. Find the slope of a line parallel and perpendicular. So there's 2 actual answers to this one. First off, this line, if I wanted to say the same line again, I'd just write the same thing. I'd write y equals 1/9 x. It has the same slope, and the slope-intercept might be -4. But instead, I'm just going to write -7. So it's got the same slope. That means parallel. Next thing I'm going to do is do one that's perpendicular. So I do y equals, and instead of doing the same slope, what I'm going to do is I'm going to flip the slope upside down, so I'm going to make it 9/1 and make it negative. Now I'm going to simplify that a little bit because 9/1 is just 9. So we have negative 9x. So I've changed my slope, and I just need to make sure I don't accidentally pick the same line, okay? So I'm going to make sure I don't accidentally pick the same line, so I'm going to put, what's a number that's definitely not 4? How about 100, okay? And so that would be a perpendicular line. Determine whether these 3 ordered pairs are solutions to this equation. Well, this system of equations. So it needs to work for both of them. So I'm going to start at the top, and I'm just going to see which ones work for equation 1. 2, 8. If I do 2 minus 8, I don't get, that doesn't work in my first equation because it's supposed to equal -4, and it gets -6. Okay, so that one's out. I don't even need to check it in the second equation. The second one, I'm going to plug in -2, -2. If I plug in -2 minus 2, it equals -4. It says it's supposed to equal -4. So guess what? It works in the first equation. So the next question I have is, does -2, -2 work in the second equation? So I'm going to plug in -2 for x and +2 for y. And let's see what we get. We get -2, which is the same. So this one actually works for both of them. Great. What if we flip it around and we do the same thing, except let's go back and we're going to check in the first one. 2 minus 2. Does that equal -4? 2 minus -2 equals +4. So that doesn't work in our first equation. So the only one that works is B. Solve the system of equations by graphing. I love graphing as my solving. Now, I might do a couple things to graph this, but I'm really just going to graph it in a graphing calculator. But let's say I don't have a fancy graphing calculator and I just have a handheld graphing calculator, okay? Or let's say I wanted to graph it by hand. So the first thing I'm going to do is I'm going to want to solve it for y. So I'm going to solve each of them for y. The first one, if I add y to both sides, I get y equals x plus 6. And that's done. The next one, if I get y by itself, I get y equals negative x plus 2. Okay, so those two don't have the same slope. They have different slopes, so they definitely intersect. And so if we're going to solve it by graphing, what we do is we go ahead and graph each of them. And then we find the point of intersection. So I'm going to go up 6, 1, 2, 3, 4, 5, 6, and then have a slope of 1. The second one says we go up 2, and we have a negative slope of 1. And so we intersect here. Now, if I was doing this on graph paper or using graphic calculator, I get the right answer. But since I don't have a graphing calculator, one thing we can do is we can just set these two equal each other. They both equal the same y. So we just need to figure out what the x would be that would match. So that would be x plus 6 equals negative x plus 2. I'm going to add x to both sides, and now it's 2x subtract 6 equals negative 4. So x equals negative 2. That's only one part of my solution because that's my x coordinate, but the question becomes, what is my y coordinate? If I plug in negative 2, what would the y have to be? Now, I can go back into either one of my equations, and what you're going to see is that the y, if I plug in negative 2, has to be positive 4. So my solution is the point of intersection, negative 2, comma 4. So I solved it by graphing, but then I really solved it by substitution. Solve the system of equations by the elimination method. Now, the elimination method is where we try to get the two equations to crunch together to cancel out or eliminate one of our variables. We do that by trying to get them to be equal but opposite. So I want you to notice that the bottom equation has a 3x in it and the top equation has a 9x. So what I'm going to do is I'm going to multiply the whole equation by negative 3. Now, the reason I'm doing that is because if I do that, then I would get negative 9x minus 24y equals negative a whole bunch. Negative 3 times 24 is negative 72. All right, so I multiplied it by 3, and I can do that because algebra says I can do that as long as I do the same thing to both sides. And what I found was now, if I look at the two equations and I put them right on top of each other, you'll notice that we have a 9x and a negative 9x. And the elimination method is to go ahead and crunch those together and add the two lines together. And that would cancel out. And I would end up with negative 19y equals negative 57. And so y would equal 3. And so, yay, I've got 3. Now, what do I do with that 3? I'm going to take that and I'm going to plug that back into my equation. And it turns out x needs to be 0. So my ordered pair is 0, 3. Jen Butler has been pricing speed pass train fares for a group trip to New York. The 3 adults and 4 children must pay $80. So 3 adults plus 4 children must pay $80. If they only take a second group, and the second group only has 2 adults and 3 children, they save some money because there's less people. It's $57. Our goal is to find the price of the ticket. Okay, so there's a different price for the adults and for the child ticket. So what we're going to do is set up our system of equations. Notice I just kind of read it as I went and wrote down just like that. If you felt more comfortable going x's and y's, the one thing I'm going to tell you to do is if you're going to set up a system of equations with x's and y's, please, 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 somewhere, just make a note. The x was the adult ticket price, and the y was the child price. So definitely make a note somewhere of what your variables are representing, because you don't want to get the right answers and then put them in backwards. All right, so we can solve this any number of ways. The way that jumps out at me is usually elimination. So what I'm going to do is I'm going to get them so that they're equal and opposite. In order to do that, I'm going to multiply the top equation by negative 2. No, I'm going to multiply it by positive 2, and I'll multiply the bottom equation by negative 3. Okay. The reason is because I want to cancel something out. And I know that if I can turn this 3 and the 2 into a negative 6, a least common multiple might be 6. So I want to cancel out my x's. If I do that, I'm going to rewrite my equation as 6x plus 8y equals 160. I just multiplied the first line by 2. The second line would end up being negative 6x minus 9y equals, and negative 3 times 57 is a lot. It's negative 171. All right, from this point, you can look at it and you say, well, now that we have these together, we can cancel them out. These cancel out, but these, when we add them together, 8y minus 9y is negative 1y. These, when we add them together, is negative 11. So guess what? Y equals 11. And so just like that, we have the y value. All we have to do is then plug it in to find the adult value. So I'm going to do that by plugging it into the one on the top. And if I plug in 11 for my y, I would end up with 44. And if I subtract that, I end up with, not too bad, I end up with a 3x equals 80 minus 44 is 36. So x equals 12. And so I have my two values. So back in context, I need to say, what does 12 and 11 represent? Well, 12 is the adult price of a ticket, and 11 is the child price of a ticket. Identify the degree of each term of the polynomial and the degree of the polynomial. Okay, so each term, there are 4 terms, 1, 2, 3, 4 terms. Terms are separated by a plus or a minus. So it's each cluster like a cluster of granola. So our first term has degree 3. Now, what I'm looking for is I'm looking for the exponent on a variable. And if I look at the exponent on each variable, that tells me the degree of each term. Now, the degree of the polynomial is the biggest one. So we'd say degree of this one is 6. State the degree of the polynomial and whether it's a monomial, binomial, or trinomial. So first off, I'm going to look at my terms. 1 term, 2 terms, 3 terms. Terms are separated by plus or minus. Okay, so we have these clusters of terms. And what we want to do is we want to go ahead and say, how many terms is that? Is that 1 term, monomial, binomial is 2 terms, or trinomial, 3 terms? Well, that is 1, 2, 3 terms, so it is a trinomial. The other thing we need to answer is the degree. So we're going to look at the degree of each term. That is the total number of exponents on variables. We have 2 plus 2, a degree of 4. 5 plus 4 is a degree of 9. And 2 plus 8 is a degree of 10. And so my largest degree is 10. So we're going to say it's a 10th degree trinomial. We always just pick the largest term when it comes to the degree of a polynomial. We have 2 polynomials and we have to add them. That means we're just going to line them up and add the like terms. So like terms there is I'm going to get negative 1b squared. Then we have like term there and there is going to cancel out. And like term there and there is going to be a positive 1. Subtracting polynomials. I don't like to subtract polynomials. I distribute the negative and then I add them, okay? So when I do that, I'm going to also rewrite it underneath. So the first one I have is 3x cubed. Notice that there's no x squared term. Minus 8x, so I left some space for this x squared, plus 6. Underneath, I'm going to write, after I distribute the negative, I had positive 8x squared, and then I had negative 5x, and then the negative 9 becomes positive 9. I lined them up, so that'll make my combining a little bit easier. Now that I distributed the negative, I don't need to subtract. I'm just going to add the lines up. And I get positive 15. I get negative 13x. And then I get positive 8x squared. And then I get 3x to the third. Multiplying two monomials isn't too bad because we're going to multiply each piece separately. In other words, I'm going to multiply the 3 times the 7 to give me 21. I'm going to multiply the w's together, so I have a w with an exponent of 1 and an exponent of 3, so that's total w's of 4. And then we have z's, and so there's 2 and 5, so a total of z to the 7th. So this is my combination. Now, if I have an exponent outside of a parentheses, I can go ahead and bring that inside, but I'm going to make sure I apply it to each piece. So first we have 2 to the third, and then each of the variables with exponents, we're going to multiply those exponents together. So a to the second is going to become a to the sixth, b to the third becomes b to the ninth, and c becomes c cubed. One last thing I want to do is I want to simplify that. 2 to the third is 2 times 2 times 2, or 8. So I end up with 8, a to the 6th, b to the 9, and c to the 3rd. Now, the number one mistake I see when people see this problem is they want to just go ahead and distribute that exponent n, although that will give them the wrong answer. The truth is that they need to treat this as if it is two things multiplied together. In other words, the same thing multiplied by itself 2 times. So when I write it like this, you'll see that what we really have to do is we have to distribute that out or FOIL it. And so what we're going to end up with is 25a squared. And then after we end up combining the like terms in the middle, we're going to end up with negative 60ab. And then finally, we're going to get positive 36b squared. All right, simplifying this one, it starts by looking like I should just distribute this in, but you should not do that. Don't distribute in an exponent. What this really means is that we're multiplying by the same thing twice. That's what an exponent of 2 means. So we're going to write it out, and then we're going to distribute, and then we're going to combine like terms. So the first thing I'm going to do is do the 5m to the third times 5m to the third, so that's 25m to the 6th. We add the exponents when we multiply terms. 5m to the third times 7 is going to be 35m to the third. And then we do it with the 7, and we also get 35m to the third. And we get that 49. So altogether, we get 25m to the 6th, 70m to the third, and 49. So don't get tricked by doing that exponent and distributing the 2 in. Okay, don't distribute the exponent. Actually write it out and then multiply. Dividing monomials. Now notice that these are monomials. In other words, there's just one cluster at the top and one cluster at the bottom. We're going to treat each type of the problem separately. So I'm going to look at just this part right here, just the numbers, and simplify that. Well, that's not too bad because negative 64 divided by negative 4 is just 16. Now, if I look at the f's, I have an f on the bottom, and I have just 1, and then I have f cubed on the top. So I'm going to actually end up subtracting those and just get f squared on the top. In the same way, the last part is 12 minus 4, so I end up with g to the 8th on top. And I don't even have a fraction anymore. There's no denominator because everything on top canceled out with things on the bottom. What we have here is we have a negative exponent. We also have a set of parentheses. So either way we want to do it, I'm going to deal with the negative first. So the first thing I'm going to do is deal with that negative by saying a negative exponent flips the fraction upside down. And you might say, but there's not a fraction there. Well, there is a fraction there. It's just over 1. So if I wanted to get rid of the negative exponent, I would have to flip what's inside that parentheses upside down. And that is effectively what the negative exponent has done. The next thing we need to do is we still need to bring in that fourth exponent. 1 to the 4th is just 1, so that's not too bad. And then on the bottom, we just need to multiply those out. So I'm going to say x to the 28th and y to the 16th. simplify, we've got a negative exponent, and then we've got a fraction on the inside. So the first thing I'm going to do is I'm going to deal with the negative exponent, okay? And so what a negative exponent does is it flips the denominator and the numerator. So I'm going to turn this into a positive exponent. So it's now a positive 3. Now how do I get that from a negative 3 to a positive 3? I take what's in the fraction, what's in the parentheses, and I flip it. I flip that fraction upside down. All right, so now I don't have a negative exponent, but I still have a 3 on the outside. Now, since this is all one term, all of this, there's no plus or minus, we can go ahead and distribute that 3. In other words, we can go ahead and put y squared times 3. And so I'm going to go ahead and do that, and I get y to the 6th. 2 to the 3rd is 8. I've got a 0 times 3, so that's still 0. And a 3 times 3, so that's 9. So I'm almost done. I need to see if there's anything I can simplify. I noticed that there's no negative exponents. That's good. But this 0 exponent actually means that I can cancel this whole thing out. So my final answer ends up being y to the 6th over 8 to the 8b to the 9th. Divide. Although notice that this actually has 3 separate things on the top. I can't just cancel out in one section. I need to treat each of them. So the question I really have is, what can I take out of all 3 of them? Okay, so can I take a 4 out of all 3 of those? And the answer is yes. I would end up with 4c to the 3rd minus 3c to the 6th plus 3c to the 8th. Okay, that's if I just did the 4. Now, the other thing I'll try to do is try to take out the c's. Can I take 3 c's out of each of them? A c to the 3rd? Yeah, I can. In fact, this one's going to work out pretty nice because I end up with 4 minus 3c to the 3rd plus 3c to the 5th. Divide a trinomial by a monomial. Now, we need to think about how we can take everything we can out of all 3 of them. So the first thing I'm going to do is try to factor the numerator, if at all possible. Okay, so I'm going to factor the numerator. Is there anything I can take out of all 3 of those? Well, I can't take out a 5 from all 3, or a 4, or a 2. So actually, the answer is I can't take any of the numbers out of all 3 of them. But all 3 of them on top have an n with an exponent. So I can actually take an n to the 5th power out of all 3 of them. That would leave me with 5 minus 12n squared plus 4n, just like that. So at this point, if I look at the bottom and I go, you know what? Now I have an n to the 5th on the top and the bottom. And so when we simplify fractions, what we're really trying to do is cancel out something, a factor on the top and the bottom. And so my final answer for this is just going to be 5 minus 12n squared plus 4n all over 48. Pay attention though to when you're answering questions like this, if they want you to split this up into 3 separate pieces, then you could do that as well. Factor by grouping, check the answer. Okay, so the first thing I want you to notice is that this has 4 terms. So the first thing I'm going to do is just assume that they're in a nice group order for me. If I group the first 2 and say, what can I take out of both of these? What goes into a 4a also goes into 15bc? And the answer is a 1. That, like, literally only a 1 would factor out of that. And if I look at the second one, we'll see the same problem, only a 1. So nothing really special seemed to be happening. So what we're going to do is we're going to reorder these a little bit and see if that unlocks the key to this problem. So what I'm going to do is I'm just going to switch these 2 around. We could switch a different pair and try it and see if it works. I'm just switching those 2 at random. Well, not at random. The reason I switched those 2 is because I kind of like that it would put the ones that only have 1 variable together and the ones that have 2 variables together. So now what you'll notice is if I try to factor out of the first two, there is something I can take out. It's not much, but it's a 4, and that would leave me with an a plus 3b. And if I look at the second set, and I say, what can I take out of both of those? And the answer is I can take out not much, but I can take out a 5c, a positive 5c, and that would leave me with 3b plus a. Okay, so that seemed to help me, but we don't quite have the same thing in both of them. So I do want you to notice that what's inside the parentheses is very, very similar. In fact, it's just the same thing in a different order. Since addition is commutative, we can say, yeah, that's actually the same thing. 3a plus 3b is the same as 3b plus a. So we can actually write our answer as two answers, that a plus 3b, and then the other parentheses, we're just going to put the other thing. In other words, what do we have left on the outside? Factor completely. This one makes me think before I start. What I want to think about when I factor this one is I want to take out any greatest common factor. So GCF first. So is there anything I can take out of both of them? And the answer is yes. I can take a 2 and an x out of both of them. And that would leave me with 4 minus x squared. Now I can be pretty excited and be like, that's the answer, but it's not the answer because there's more to do. It says factor completely. So I'm going to look at what's left in the parentheses, and I'm going to go ahead and do a difference of squares because I see that I can square root 4 and I can square root x squared. And so I'm still going to have a 2x on the outside, but now I'm going to be able to split it into two things. The square root of 4 is 2, square root of x squared is x. So I have 2 and x, and one time it's minus and one time it's plus. And so that is completely factored. Factored completely. This is a binomial. There's only two terms. So the first thing I'm going to look for is a greatest common factor. Is there anything I can take out of both of them? In this case, only a 1 would do that. So that's not going to help me. So the next thing I'm going to do is say, is it a special binomial? There are two special binomials. So there's the sum of cubes, or difference of cubes, and then there's this sum of, or this difference of squares. I almost said sum of squares because sum of squares actually doesn't factor, but since this is a minus right here, and both of these can be square rooted, they're both perfect squares, then I can jump straight to my answer. This is a special pattern, and so it's the square root of the first one minus the square root of the second one. And then we do the same thing, except this time what we do is we put a plus in the middle. And the reason this works is because if we were to try to multiply this back out, the middle parts would end up canceling out. We get positive 7x and negative 7x. And that's why when we're done, we get just two things instead of having a normal trinomial. Factor. So factoring this trinomial at first looks very intimidating because we've got some pretty ugly numbers, but more than that is that we've got numbers in front of our lead coefficient, or our lead variable. So what that means we need to do before we try to find two numbers that work is we need to multiply the first coefficient and the last coefficient together. So 14 times 25. So what we're going to try to do is find two numbers that multiply to whatever 14 times 25 equals, but also it has to add to the number in the middle, which is negative 39. Okay, so we could run through all the options and try to guess and check, okay? But I actually noticed something special about this one. What I noticed is that negative 39, if they add to give me a negative, but they multiply to give me a positive, then that means that they both have to be negative because the negatives would cancel out when they multiply. And what do you notice? Well, we have negative 14 and negative 25 do actually add up to negative 39. So that saves me a little bit of work trying to find two special numbers. So the next thing I do is I like to use the split the middle term method for factoring. I take the middle term and I keep the other parts the same, but I split it. So rather than writing negative 39, I use my two special numbers, in this case, negative 14, and I put the variable with it, negative 14y, and then negative 25y. And so I know that I'm still have negative 39y. I've just split it into two pieces. And I pull down what I have at the beginning, 14y squared, and I pull down what I have at the end, which is 25. And from here, I have four things. And I'm going to go ahead and factor by grouping. And you'll notice that factoring by grouping looks pretty straightforward here. 14y, and that would leave me y minus 1. And then I have take out a negative 25, and I get, well, y minus 1 again. And so my two factors would be y minus 1 and 14y minus 25. Factor the following trinomial by grouping. I love factoring trinomials by grouping. I used to avoid factoring by grouping because I didn't get it. And now that I get it, it's my favorite way to factor. So the first thing we're going to do is look for GCF. Is there any GCF? Can I take anything out of everything? Nope. Okay, so the next thing we're going to do is we're going to multiply A times C. In other words, what is 14 times negative 15? So 14 times negative 15, that's a big number, but let's do it. 14 times negative 15 is negative 210. No, I'm doing some math in my head, so I gotta be careful. I'm gonna pull out a calculator and do the math just so I'm not making any mistakes here. All right, I was right. It's negative 210. Now, what we're trying to do is we're going to list all the factors of AC. Now, some people try to guess what this is, and they're trying to make that 11 in the middle. But what I do is I just list them all. I know there seems like there'd be a lot of them, but let's try it. I'm going to start with 1 and 210. 2, well, if I divide 210 by 2, I get 105. 3, okay, well, I can do 3. 3 does go into 210, gives me 70. 4 doesn't work. 5 goes into 210. If I divide 210 by 5, I get 42. All right. I can do 6. Yeah, I can. If I divide 210 by 6, what do I get? 35. If I divide it by 7, what do I get? 30. If I divide it by 8, does it divide by 8? It does not. If I divide it by 9, it doesn't divide by 9. Does it divide by 10? Yeah, 10 and 21. Now, I ran out of room, so I'm going to stop right here. And hopefully, in here, I've got my 11. So I didn't have to do a lot of guessing, and this can feel like magic if we're just pulling out. But I'm looking for two numbers that when they multiply give me negative 210, and when they add give me 11. Now, I did make a little bit of a mistake here because I didn't put any negatives in my factors. But I know that since they multiply to give me a negative number, one of them has to be negative. Since they add to give me a positive, then I know that the bigger one has to be positive. So I'm going to put negative, 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 negative. For my negative side of those factors is the smaller ones. Now, if I look at these, I need to find two of them that add up to equal the middle term. So if I look at all of these factors I have here, if I add them up, I actually did get far enough to find 11. And so what we can do when we're factoring by grouping is we then split the middle term. So I'm going to go ahead and just pull the first part out and pull the last part out, 14y squared, and then minus 15 on the end. But then I'm going to split the middle term into those two factors I have. So minus 10y plus 21y. Now, if you get it backwards, it's okay. It's still going to work out. Now we factor by grouping, which says, let's look at the first two things. Is there any common factors? Yes, I can take out a 2 and a y. That would leave me with 7y minus 5. If I look at the second two, is there anything I can take out? Yeah, I can take out a 3. If I take out a positive 3, that leaves me with 7y minus 5. Well, guess what? We've got the same thing in the parentheses, which means I can go ahead and say that 7y minus 5 is 1/2 of my factors. The other factors are 2y plus 3. Where did 2y plus 3 come in? Well, 2y plus 3 is right there, and that's where we get that 2y plus 3. This is a binomial, and it actually straight up tells us, says use the sum of cubes formula. So first off, that means we're going to need to figure out what the perfect cubes are in this problem. So I'm going to cube root the first thing and cube root the second thing. So what's the cube root of x cubed? It's just x. What's the cube root of 125? It's just 5. And our formula is pretty much this. We take that and we keep the sign the same. And then we're going to make another set of parentheses. And the first thing we do is we take our first thing and we square it. So x squared is going to be just x squared. And then we multiply our two pieces together. So 5 times x is 5x. And then the last thing we need is we square the last number. So we square the 5 and we get 25. Okay, we need to watch our signs. The way I remember it is the same, the opposite, and the last one is always positive. So since this was a sum of cubes, I can have a plus in the beginning, the same, and then I'm going to put the opposite sign as my second one, and my last one is always positive. If this was a difference of cubes, I'd just switch those out. I'd use the same, opposite, and always positive. Back to the following expression completely. Now, first thing I'm going to do is anytime I have to factor is I look for a GCF. Now, this one doesn't have any GCFs. But now that it's a binomial, there's only a couple things I can do. It has a plus, and I can cube root both of these. So this is a sum of perfect cubes. So the first thing I'm going to do is I'm going to cube root both of them. So that's 2x and 5y. The next thing I'm going to do is I'm going to square what I had there. The 2x squared is going to be 4x squared. I'm going to multiply them together, and that's 2x and 5y makes 10xy. And I'm going to square the last part, which is going to be 25y squared. Now, I need to get my signs right. Now, the first sign is the same as what I started with, plus. The second one is the opposite of what I started with. And the last one is always positive. And that's actually done. It's tempting to look at this and say, hey, can I go further? But if I took out greatest common factor to begin with, then the answer is no. Add any questions in the comments below. Let me know if you need anything. I'm around.